Okay, hello everyone. So today we're going to have the oral presentations of your project proposals. And before we get started, was it you, Juan Vargas, Juan Sebastian Vargas, who asked a question regarding the not being able to share the collapse on a folder, a drive?
Yes, sir.
Okay, so I was wondering what to do. Um, this problem only, how many people, how many students do we have from the escuela? Is it four students, four teams? I think it's four, right?
Yes, four.
Four, right? So yeah, because with them, I don't know if you guys are using GitHub. Any of you are using GitHub to share the files or anything like that? Something like that, a repository, file repository. Hello, nobody is.
Not yet, but
Do you know how
yes.
to use it?
Yeah,
So
we know how to use it.
No.
But so far we haven't.
but you know how, so I was wondering whether you could like maybe work on GitHub. That would be one solution. Do you think that would work? So you can work there and share the files there. Do you think that would do?
Yeah, I think that might work. Yeah.
Okay. And the other thing that I could do, the other solution would be that maybe for each one of these teams, because the problem is you as students, you are not allowed to share these files. But what I can do, we as professors, we can do, we can share the folders. So what I could do is maybe that's another solution, that I create a folder for each one of your teams, these four teams, so you can use them to work and share files there.
Okay.
So that will be. I think I'll do that anyways. Okay, so I'll create a folder for the four of you guys, the four teams rather, so you can like maybe use those folders to share your files. Okay.
Okay.
Okay, I'll do that, but I haven't done it yet. But those were the two solutions that I came up with. So the first team is ready.
Yes, teacher.
Yes, sir.
Okay, so please be.
I will share the presentation.
Yes, please do. So let me see. Now I have the camera finally, and I'll continue doing that. So hello. So be brief, no more than 10 minutes to present, and focus on the problem and the data set, and especially, try to describe, at least in general terms, the network that you're going to deal with, okay? And then we'll give you a feedback. So what we are going to do is you present, while you're presenting, we are not going to disturb you, interrupt you. And at the end, then we can ask some questions, okay?
Okay.
Okay.
No problem.
Okay, so please get started.
Okay. Thank you, Professor. So, okay, we're going to start, so for the sake of time. So we're Laura, Juan, and Johan. We're going to present viral marketing and network science in retail as a topic. So we can go next slide. So we provide you here a quick agenda so you can make sense of our presentation. So we're going to make a context in a problem, a literature review, a case study, and then the data set that comes with the case study, and the proposed approach. So I can hand over right away to Johan here.
All right, so we're going to start with the context problem. In this case, we have to say that nowadays, the effectiveness of recommendation systems plays an increasingly crucial role in the process of achieving product sales. For this reason, the fundamental challenge of understanding the complex dynamics of social networks is presented, especially in the field of viral marketing. Therefore, we expect to accomplish the following points that we can see in this slide. The first one is achieving more effective product recommendations. The second one is increasing sales, and the last one
Okay.
And the last one is enhancing customer satisfaction. We
Sorry,
also
sorry, excuse me, just a second. Maybe Laura, would you close your, or what is it? Because we hear like an echo or something, or some interference there, some noise. So I
Okay.
don't know because of.
I mute.
Okay,
Sorry.
continue, please. Sorry about that. Sorry about. Continue, please.
okay, no problem. Then finally, we got to say that we got to mention that this study or this project investigates how enhancing the people also both feature on various platforms can lead to more effective product recommendations. This next slide, please. So the approach to address this challenge, we have adopted a network science-based approach. We will use models to understand and analyze the connections between products, thus improving the effectiveness of recommendations. Consequently, we want this study to focus on a deep understanding of the dynamics of social networks, with the aim of design effective viral marketing strategies. Next, please. So in this case, in the literature review, I think my partner Laura is gonna do it.
Sorry, I mute.
Okay, go ahead.
Literary review. We encountered in literary review three principal ideas who create the context and the content of the project. One is the mechanisms of the viral marketing, word of mouth advertising and cascade effect, and social advertising campaigns in online social networks. Um, Viral marketing operates as a strategic approach and aimed to leverage existing social networks capabilities for promotion products and disseminating opinions. And this mechanism is rooted in the type of the word of mouth. Advertising that triggers is fascinating a cascade effect kind to the spread of epidemic. Um, as we proceed with the case of a story, keep this mechanism in mind. It forms the basis of the exploration in the document, the dynamics viral marketing. This document focuses on analyzing the recommendation referral program implementing by the large retail. uh, we encounter with the two key points. One, this is analysis of the retail triggers for the viral marketing, and second is count and experiments. This case of study provide some insights. One insight is identification of the individual create interconnected networks, and second is understand of the dynamics of the product connections. This is in science serve as a foundation for the next phase of our project, where we aim to leverage this understanding to refine our recommendation algorithms and create marketing strategies.
Okay. So we're going to explain here the data set in a high level overview. So left, you'll see data set statistics. That's the main data set here, because this is this is a network already being modeled. Okay, you have to mute yourself, Laura, for a moment. Don't worry, you can just do that. Okay.
Okay.
Yeah, take your time. No problem. Thank you. That's right. Okay. So yeah, very quickly here, you can see on the left here the number of nodes, almost 400,000 nodes, and edges, more than 3 million edges. The rest of the statistics, we don't understand them because we haven't studied these topics yet, but We can say, for instance, diameter is the most understandable of those. Might be interesting too. And we also have the metadata here of the dataset. This metadata, it's the actual product table. So if we were in regular network, if we were in regular data analysis, this would be the main table, not the metadata. But here, because we're studying network science, the actual main table is the one on the left, and the right one, and the metadata one is the one on the right. Sorry. So we can make sense of the primary keys, which are the products. So no problem, we have both of them. Main thing here is that the connections between nodes here are products that are being co-purchased. So if I purchase product I, and then I purchase a product J, I have a connection between I and J in the data set, basically. Basically, it's that. We can go to the next slide now. And finally, we're going to propose here a network science approach for using small word model. So we think in our team that framework of viral marketing can have the small world approach, because when a small world network grows, it maintains relatively short paths between any two nodes. The reason is because it grows logarithmically. So if we think of it like an O of n framework, where the
What happened? What happened?
I don't know what happened. Sorry, Professor.
No, go on, go on.
Okay. So no,
we're not looking at the file anymore, at the presentation file.
In the meantime, Laura, or okay, yeah. Just for the sake of time, I'm gonna go straight to it. So again, a small world approach is because we think we can model this, because since the topic here that we're presenting is viral marketing, the interest here is to potentially reach a large audience. So all these features, all these characteristics can be modeled by a small word model, where we can specialize, or we can optimize for the shortest path between two nodes. And as I was saying, logarithmically increases, or a pace that is logarithmically means that it will grow slower than the actual length of the network. So that's the main idea. That's the most interesting thing there. You can see there a picture that illustrates it. Professors can maybe know this picture. For us, it's just an overview, a quick glance of what it is, because we haven't studied it, but we will, hopefully. I remember that Professor Alfonso answered a question about this, about the small world, where he said that a small world network is typically large in size. So this fits perfectly with a type of network that we're studying here, that is basically products of Amazon, basically products of some merchant that are going to be very large. So yeah, that's the main thing. Just to say, neighbors in between nodes are typically connected to each other here in a small word network. So we can go very deep into that, but I think that's the most of it. So we can finish in here. So that's it.
Okay, good.
Yep.
Okay, thank you. Professor, any comment, any question, and everybody else?
Okay, let me share my screen, please.
Okay.
I have a few observations.
Sure.
Okay. 1 second. Okay. Uh, are you seeing? Are you seeing?
Yeah, the PDF.
Okay, this is a classic article about viral marketing.
Yes.
One one possible problem that I see with your proposal is the size of the size of the network. Uh, Yuri Leskovic, the author of the article you showed us, is specialized in very large networks. Okay, and he has special tools for analyzing that networks. When you have networks of millions of nodes, it's you must have a very you must use GPUs, etc. Okay, my suggestion, what you are seeing here is it's an article that compares different models, smallware model, preferential models. Look, a random model, a lattice model, a smallware model, preferential attachment, and look the size of the networks. Okay, the size are not so big. Uh, I suggest if I'm gonna I'm gonna I could send you this article for 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 that you could compare this article with the one you are seeing. I'm not saying that you have a very good idea. Viral marketing is it's a very important topic in network science. But I suggest seeing this article and try to to use uh, networks not so big. Okay. Uh, One of the objectives of this first proposal is to choose an article and try to replicate the article. And and one of the main objectives of the mini project is to replicate, I mean, to try to replicate the networks that are in an article and to learn to use the tools that we are going to use, NetworkX and Gephi, etc. And and the final project, it's an original project that you must do. Okay, so this first project is
No, but Professor, this
okay.
sorry, this is for the whole, class project,
This is for the final project.
Yes, for the 10 project, Professor.
Okay.
Then I think the network, the size will be okay, right? Just to be remember that
Okay.
if the network maybe is too big, then maybe just take a portion of the network or something like that. That's what we've done in the past, right, Professor?
Okay. So you can choose the article, and if the network is too big, try to reduce it,
Okay.
and use the I guess small networks are important networks, but you have to analyze if they are adequate for recommendation systems. The networks that are used for recommendation system are bipartite networks.
The idea is use a small model because the data is so big, and when use this model, create a mejor, the best research and analysis of the data.
Okay.
Professor, maybe some idea, general idea for everyone about how to split the network, or maybe just take a subgraph of the network, or subnetwork rather, because you cannot just, for example, randomly sample the nodes or something like that. Just take maybe a portion that is somehow connected, right, Professor?
Yes, I guess in this session or in the next session we're going to see how we can find communities in networks, how can we construct subgraphs of a graph of a network and analyze portions of a network. So this is going to be in this session or in the next session, and but I think it's as a final project, it's a very good idea, and there are a lot of literature about viral marketing and about recommendation systems. It's important that in the end you could convince us that it's better to use network science, and that the model that you are going to do is going to do better recommendations than normal models. It's important that you have this in mind. Okay.
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 So in a summary, we can um, start investigating. You can send over the article,
Yes.
and then we start consulting you professors to enhance and tailor the model so we can see if small world model is adequate or should we change it in time. So that's okay.
That's okay.
Yes,
That's
that's
okay.
fine. Yes, fine. Yes,
And
yes.
any
Okay.
question you could ask us. Okay. Yes.
Okay. That's
Yeah, very good. Just one final comment regarding this. So the important thing is for today's presentation is, and for this project is just to make sure that you have a network, a data set that corresponds to a network, or that you can build a network from the data set. And then you also need to pose some questions, like what type of answers do you want from this, from analyzing the data set? That's very important. And then later on, you will see because we haven't started that yet, what methods would be appropriate to analyze the network, okay? But this is very good. And maybe,
Okay.
and one comment, because Professor mentioned the mining project, and I think we can post it tomorrow or the day after tomorrow, um, just to make sure how, or to understand how to analyze networks. Then what Professor was saying, our idea is to give you a small project. There are some ideas on some networks that you can pick, and so you can perform some analysis on the network shortly, soon, and that's going to be very useful for the class project, right, Professor? And that's so, as Professor mentioned, is something like replicating maybe the work that they did on some paper in the past, and by analyzing some network, right, Professor? And then we
Yes. Yes. That's the idea. Okay.
Okay,
Yes.
so we can post it I think we can post it tomorrow, right, Professor? And
Okay.
that can be done like in a couple of weeks or so.
Okay.
Okay, very good. Anyways, good, very good, good job. I think it's a good job that you guys did.
Thank
Uh,
you.
thank you.
all reactions are. Is there any question? No. So all reactions are welcome. Okay, so let's move on to the next team. I don't know. I put some of the files there. I haven't finished yet, but let me see. Somebody who is whose file is that is called named presentation? I don't know. Let's go with that one. Presentation. The file name presentation. That's by, let me see, Santiago Angorita, Laura Chacon, and Sergio Vargas.
Yes, teacher. Hello, everyone.
Okay, please go on. And you manipulate the file, please.
Okay, let me a second. Mm, moment, please.
Okay, I'm gonna share my screen.
Oh, thank you, thank you.
So you're team number 2, if I'm right?
Yeah. We are.
Can you see my screen?
Yeah.
Yes.
Thank you, Laura.
Okay.
Okay, go ahead.
Okay. Good afternoon for everyone. And our project is called Mathematical Roadmap, Network for Mathematical Knowledge. So here, the key here is the problem we want to solve is moving or movement among concepts, definitions, and theorems of mathematics. In particular, maybe in a specific area of mathematics, seeking the shortest distance for example, to create a specific or target study programs. Um, I'm a mathematician, so sometimes I have to prepare a topic for financial mathematics or very specific area of mathematics, and these guys is not need all set of theorems around of calculus, for example. So establishing visualization of the connection between theorems and definitions from one or different area is the principal problem we have uh, stating here. Um, for example, another example, if you given a point in the network of knowledge on theorem definition, proof of theorems, examples, yeah, knowledge of mathematics, and you want to move naturally to other similar ideas in the proof of theorems. That can be replicated. For example, if you have one technique for Pythagorean theorem, yeah, and this same technique is useful for another theorem. So this is a way to movement around the network. So the next question is, yeah, so how many definition corollaries mathematical concepts exist in the world? Uh, how we how can we learn about the specific subject in mathematics with only necessary requirements? So this shows it would be possible to study mathematics in different and optimizable ways if you have a very good network of knowledge of mathematics. Next, next please, Laura. So about the literature review in this problem. So maybe the principal papers are exploring the knowledge graph within a data network science as a fundamental step for representing and navigating knowledge. So the the data set here is called natural proof. It's a corpus of natural language mathematics for breaking the gap in mathematical natural language processing. Is a set with theorem definitions, and these elements are very linked by techniques and other kinds of reference between them. So this is all for me. Next, my partner is with you.
Okay, and for the case study, we refer the article Math Graph, a knowledge graph for automatically solving mathematical exercise. This article proposed the creation of a tool to solving mathematical problems, and it is based on a knowledge graph. Math graph consists of nodes like object nodes, operation nodes, and constraints nodes and float edge. In this image, we can see a general description of how to use MATLAB. To begin, the mathematical problem is enter. Here, MATLAB use natural language processing techniques to mathematical operation, and these identify key elements such as instance, constraints, or operations. Math graph use a knowledge graph specifically designed for mathematical problem solving. That part is interesting because using this relation and solving constraints math graphs applies reasoning techniques to arrive at solution to the exercise. This literature provides us with a relation structure for organizing the concepts that we wish to implement in the creation of our knowledge graph. including the extraction of information from the database containing and definitions and mathematical application. Also, it could include the implementation of tools and algorithms for data processing.
Next we are going to present the dataset, and the dataset is the natural proof dataset. Is a rich collection designed for studying mathematical reasoning in natural language. This dataset comprises approximately 30,000 theorems, statements, and proof, 15,000 definitions, 2,000 additional pages containing axioms, corollaries, and other relevant content. Next, please. For methods and models, we are going to explore the network science models that we are going to use. This provides a powerful framework for presenting and analyzing complex systems, and the models that we will be using are knowledge networks, representing as direct graph and capturing concepts and the relationships. A bipartitive graph representing relationships between two distinct types of entities, such as concepts and resources, and multi-layer networks incorporating multiple types of relationships or attributes between concepts. For analysis, we will be using centrality measures and community detection algorithms, pack-finding algorithms, and network embeddings. And these methods will help us to identify key concepts, group-related concepts, find relevant paths, and transfer nodes into low-dimensional representations. These models and methods offer flexibility, scalability, interpretability, and applicability, making them ideal for developing a RockMax tool that synthesizes knowledge domains. Next. Well, thanks for hearing.
Okay. So I don't know if I understood well. Okay. And can you go back to the presentation, please? Keep the presentation on the screen. Professor, are you there? Because it's not very clear for me the analytics, the analytical process there.
Okay, I guess in the last in the last part of the presentation, they show the analytics.
Can you
They
go
want
back
to
to the
use centrality measures to identify key concepts, and I guess they are going to try to use shortest paths to see if they're for a proof or for an algorithm of mathematics that could be an optimum number of paths, I guess. Uh, I guess they have the data, math data. I didn't know it of the, of these models of these math data. But today there are a lot of new things that we don't know. So this is the it, it's very interesting. It's very interesting. Today there are a lot of tools, of proof tools. If you want to the proof of a theorem, you don't have to think of the proof, but you can go to some tools that they do automatically the proofs. This is an important topic. Uh, I guess you have the data. Uh, you have some tools like centrality measures and paths, but maybe when we go further in the course, you could find another tools for trying to analyze these networks. Knowledge graphs are very important graphs. So the study of knowledge graphs, it's going to be very important for you
Yeah, maybe if you allow me,
Yes.
you guys, because yeah, I know the graphs, but then at the end, I don't know because you said you have there are so many theorems, there are mathematical theorems and concepts out there. So I don't know if it's gonna be a connected network, maybe a sparse network. I don't know. So maybe Santiago is raising his hand. If you can tell us, yeah, you apply these analytics there, of course, these two types of algorithms. But then, what do you want to actually find out? Like you say that maybe you expect that some key concepts, common concepts, arise there from this analytical process, Santiago?
Yeah, teacher, thank you. Yeah, first one question because the data is basically is natural language and mathematical syntaxis symbols in LaTeX language. So I question about the algorithms of natural language processing because maybe will be a good strategy for that data analysis. And about the question, um, yeah, this data set is very well linked and classified. So the theorems and definitions and examples and other concepts are referenced between them. If you have one axiom and in the next steps you use that axiom in the proof on what theorem that the reference exists.
Okay. Yes. Okay. So maybe yeah, because math is so big, like so many areas, so many theorems. So maybe I had picked some theorems that are related. So just you mentioned some mathematical symbols and that. So can you like maybe do you have any sample there of the data just to understand, for example, how a theorem is represented in the data set?
I have a
Oh,
sample, but I have in another OS the sample. I could try to download the data in this computer.
Just one sample, but maybe not right now. But if you could do it like later in the session. But it's natural language, also the theorem is expressed already as a graph, or is just natural language the statement of the theorem?
It's a JSON file where all is categorized with the names of the theorems, and the other data is presented like the metadata,
Okay. Yeah.
but I don't have here the data.
No, it's because you mentioned, as Santiago mentioned, that you guys will have like some mathematical symbols and that, but then it may be necessary to apply some, natural language process in there because just to extract the relevant information, the most relevant information. Okay, but very good. Yeah, I think it's promising, but maybe I have that question because if you need to apply maybe some natural language process in there, you need to make sure that you can accomplish that in the term, for the project, so you can solve that. Because once you have the graph, right, professor? Once you have the network, then applying these algorithms is going to be not so difficult, right, professor?
Yes, the important thing is that you can extract the networks from the website. I don't know where you could where is this information, but it's important that you could extract from the website the information and then analyze it in the tools we're going to use. I guess this is possible because
Yeah, very good, very good. I think it sounds very very nice, right, professor? It's surprising. It's interesting.
yes, it's very original project, and I guess it's a very good idea.
Yes, yes, very good, very good, very nice. Thank you, guys. So let's move on to the. I don't know. I just need to make sure that team number 5, you can write on the chat what happened to your file if I may be missing your file. So let's go to number 7. Team number 7. Number 7.
Okay,
Yes.
good afternoon. My partners are here. Yeah, it's Santiago
Yes.
and Wilbur. Yes, we are here. Okay, I'm going to share my screen.
Go ahead, Henry.
You are seeing my screen right now?
Yes.
Okay. We want to focus to target a medical issue. So our title is Network Science in Medicine for Hair Drugs Disease Profiling. In this case, as I stated earlier, we are Wilber Lopez, Santiago Rodriguez, and myself, Henry Percy. What happened here? We have uh, cardiovascular diseases or hair problems are one of the biggest issue with we have as society. And the professionals, doctors that works in this area have to work with many different situations that can change the treatment for every one of the patients. So we want to overlap in treatment in comorbidity and help this network to support tool in medical decision making for these treatments, as I stated earlier. What we observe in literature, we have different symptomatology from patients. We have different conditions. We have silent conditions, silent symptoms, or difference in symptoms for each one of the patients. We have drugs interactions, and we have additional factors that make a little bit harder to diagnostic the different patients. So what we saw is, according to literature, we have different conditions. Not all are these all are categorized as heart problems, like coronary artery disease, congenital heart defects, heart valve disease, and many others that are combined in this category as hair diseases. Also, what happens? We have silence and different symptoms. When we have silent symptoms, the time, I'm going to minimize this, the time is critical and the treatment is critical because people or patients have been suffering for these heart diseases for a long time, and just one day experience some really huge uh, difficult or situation is when we saw, or the medicals, the doctors see the effect of the problems, and it may have passed really long time. So we have to evaluate these different conditions, such as heartburn, dizziness, qué pena, sorry, dizziness, headache, heart attacks, uh, and validate what are the conditions, particularly for these patients. Also, we have drugs and drugs interaction, that modifies what we call effectiveness and toxicity, uh, and this will affect completely the treatment, because if we don't select the correct uh, medicine batch for the patient, we have maybe reduced significantly the effectiveness and the patient will not get better. Also, we have additional factors. We have age, we have gender, and have obesity, we have diabetes, we have many other conditions that also affects the treatment that a person, the professional medical people have to take into account. Uh, the older the person, the more interaction or drugs interaction are going to be uh, observed. Women are more prevalent to suffer these heart diseases. It's contrary at what we saw in many TV shows or movies, where always it's the men who have this problem. But no, in reality, it's the woman that suffer more of these diseases, and also it can have different conditions, different symptoms that men doesn't have. And well, other medical issues like obesity, as I said before, or diabetes, or many others that interacts between each them that can affect the drugs, the effectiveness of the drugs, the time of recovery for the person, and such. Uh, Let me minimize
Okay.
this for silence my microphone.
Okay, since the objective of our project is to link drugs or medication to a specific group of diseases, we looked for a project in the case study that would deal with similar problem. And we found a paper from 2023 that talks about DreamWalk, which was a project that was based on drug repurposing, which talks about reusing medicine that already exists in the treatment of new diseases or diseases that don't have a treatment. So they talk about, for example, COVID-19 was a perfect opportunity for this because instead of spending a lot of resources and time developing new treatments, we could have linked our already existing medication to treat this new disease. So the idea is to use in this paper was to use biomedical knowledge graphs, which are a type of network in which the nodes are different types of biomedical entities like anatomy, diseases, symptoms, genes, and the links between them are the relationships they share, so regulations or how they present, where they localize, etc., etc. And the idea was to use this type of graphs to link the possible medication to the diseases that need treatment. Next. Next, please. So the problem was that these graphs are very big with a lot of data, and they usually have a lot of entities in terms of genes or proteins, and some of the other entities are more scarce, like drugs or diseases. So connecting those two was not easy. So they decided to use a multi-layer approach in which they had a drug space, a gene space, and a disease space, and they try to link the disease and drugs through their connections on genes and how they interact with the specific drugs and diseases. They use different techniques to do this linking, like guild-based association, which means that we can study and characterize a node based on the study of its neighbors, and some other techniques to try to walk through the network itself, like techniques of similarity measures and random walking, which we will talk a little bit in a moment. And so we think this paper is very important and it can help us a lot because they face similar problems that we would in terms of we're both trying to link diseases with medication, and we could use some information on top of the dataset we already have, like the knowledge graphs, to enrich our network and use it in that way. And we could use some of these techniques they use to solve our problem. Next.
The network data set, pues, to start building the data set, I have been also exploring different website, for example, drunk.com, use National Library of Medicine or pharmaceutical database. This data set will contain information regarding diseases that affect the heart and the most commonly used to treat these diseases. For example, cholesterol, heartburn, hypertension, for example, is the sound the size the I have been the search. In the information is the search is the will have the data such as the name of the drug, medical condition in the which in the drug, use or what type or the size of the use, symptoms and the decide, effectiveness the drug, administration of the drug, contradiction or the effect of the drug, rating of the drug. So the variables I has been contemplating in the data set. Next, for example, is has been the initial the database I has been defined. For example, the first column is the drunk the dataset, the name drunk. The second is the size. Description is the medical the design, bueno, and other value. But for example, is the data set I has been in the moment the font, and so the next. Bueno, the purpose network design the probe. I have been find different methods. For example, the first the Neo 4G is the management data set the graph. Pues I can build in the ORS model the base of the graph. The next is I find a optimal node the path I had think the trees model, for example, random walk is similarly measure. I can I wanna use a model, for example, Yakan or algorithmic cosine or model algorithmic Euclidean, for example, and another model. I can find the optimal node path is a network traversing.
Okay. Okay, let's go back to the figure where you have the network. Yes, Professor, your comments.
Okay, this is another project that deals with knowledge graphs. I guess knowledge graph it's becoming a very important topic. There are a lot of knowledge graphs everywhere in all topics that you intend to study. I think if you are going to use multi-graph, you have to study them because we're not going to deal with that type of graphing in the course, but it's not difficult. I guess all the measures that we are going to be and all the models that we're going to study in the course can be applied to multigraphs. So the concepts we're going to see in this course are appropriate for multigraphs. So there's no problem there. I have a question about the tool that you mentioned. You mentioned Neo4j. Okay. Neo4j?
Neo4j, yes, that's a great database. That's one of the
Yes.
most recent databases where you actually store the data as graphs already, you know, so that's a specialized database just for information as graphs. Neo4j.
Any of you have experience with Neo4j, or why do you choose that tool? It's a question
Well,
for you.
I am currently in a class in a database class,
Okay,
an
okay,
advanced database class, and we're gonna touch that. We're gonna work with Neo4j, so I thought we could use
okay.
that as
Excellent,
well.
because this is an excellent tool. It's becoming very important. It's it this tool integrates all centrality measures, all community. It's it's a very big tool. It, in this course, we're going to use tools more classic because I guess Neo4j is a very advanced or a very recent tool. But if some of you have experience or have to deal with that tool, it would be very good to do it because we can learn from what you discover about this tool. It's a very solid because it's based in it's a big company. The I have seen some studies and I have touched a little bit the tool, and it's an excellent tool. It's a very complete tool. So it's, I guess it would be a good experience if you could work with that tool. Uh, I see a little complicated, very big project. I don't know if there's a way to reduce it to work a part of the project.
Well,
But I
we
don't
thought
know
that
if it's my impression. But you are trying to cover too much. Too much. I don't know if
well we could limit the diseases we could work on to a smaller group. So not all the cardiovascular diseases, but just some of them. So we could reduce the scope that way, I think.
okay.
Yes, yeah, I think the main challenge here is just to build a network. Once you have the graph, the network, then you can just analyze it as you want. But yeah, the main problem and the basic problem there is just to build the network, the graph, based on those that information about the diseases and that. So maybe reducing to a particular disease would be a good idea.
Yes.
Okay, thank you.
Okay, very good. I don't know if you guys. So that's the main problem, and maybe that would be a nice idea to that you could use a Neo4j. I don't know.
Yes.
Has anybody used a Neo4j here among the students? Neo4j? You have Santiago? One.
Yeah, Professor, I have a question about that framework. Is on Java script, yeah, right? This framework is writing on Java, but not are not our similar framework on Python or Julia maybe? No.
I'm not so sure about that, because it's I don't know what the language to manipulate the data there is.
Okay.
One of the guys who has used it, so has any answer to Santiago's question? Some of you guys said, right? Paula, you said you used it. Paula and one, I think it was one David, right? Have you used it, or who
Yeah,
has?
I have used it, but just to check the information on some graph, but I don't have a lot of expertise.
And did you program like any of the actions there? Like reading, writing on the database.
No, I haven't done
What
that.
language did you use there?
No, I haven't done that. I just use it to build information on some of the graph and to understand the
Okay.
connections there.
What about Paula or any of the other guys? And that's very good, because you can actually manipulate graphs as directly in the databases. That's a specialized database just to manipulate to store graphs directly. Okay, so that would be a nice idea, but I think, yeah, Paula, do you have anything to say regarding that? How you used it? Please, can you share that with the class? Paula? Paula? If you have any problem with your mic, you can use the chat to share your information. Okay, very good. Anyways, so yes, again, like in the previous the math project, just will be there, like just to help you with any of the issues that can come up.
Okay, thank you.
Very good, very good. I think it's a very nice project as well.
Thank you.
Okay, so let's move on to I think there were some problems because though I opened the zip file, then at the end when I uploaded it, it didn't actually upload the files. But now I'm correcting that. Thank you for letting me know. Let's move on to team number 8.
Okay, good evening.
Good evening.
Okay, so is everyone ready?
We are.
For my team, is everyone ready? Okay.
Ready.
Okay, so I will share my screen then. Okay, so you're seeing my screen, right?
Yes, we are.
Okay, so good evening. So we are Freddy, Stephanie, Jorge, and who is speaking, Manuel. We are going to present to you the project for the class that we titled Bogota on the Move, Decoding Transmillennial Trunks Efficiency. So for this presentation, we're going to share with you the project goal and scope. We are going to show a little bit of the literary review that we perform, the case study referring to the challenges that we have for our particular implementation that we propose, an explanation of the network dataset, and finally the proposed network that we came up to. For the goal and scope, so what we propose is to analyze the efficiency and identify different problems in the nodes of the public transportation network of Bogota. As you know, the transportation in a city, and especially a big city as Bogota, is a quite complex issue. It requires a lot of information, a lot of different data sets from different instances. So that is why we scope and we limit the project to only modeling the transportation distribution through the feed in and feed out of Transmilenio system trunks. So what we mean here is we are only going to take Transmilenio trunks, not SITP or anything like this, just the trunks, and we are only going to use the feed in and feed out information. So what is this? Is when the user enters to any station or leaves the station, because we are not going to use any other data sets. We are going to speak about this further in the presentation, but that is our main goal, our main scope for the project.
Okay, for the literary review, we found some studies where networks and public transport is highlighted. The first one is Dingluo and Other Cats. They propose a new graphical representation of public transport of 8 different cities. This representation explicitly incorporate waiting times, travel times, and transfer times, all obtained from early data. This study helped to identify patterns, weakness, and strengths of the transport infrastructure. The second one is Shamun Kappa et al. They are from Beijing, China. They analyze the efficiency, detect problems and segments in the system according to structures using various networks parameters like connectivity, centrality, and cluster coefficients. Later, we have Bellamy et al. They use a complex network theory to identify small words and nodes with direct impacts. In this research, the network theory is used to understand the public transport of buses and subway trains. And we have the application in Bogota in a study from Airways et al. And in this model, they explore a passenger entrance but not exits. The approach made for this network was to implement a bipartite network and perform an optimization model. This model is the most similar to our case. Yeah, this is all.
As a case study, we talk a paper of public transport networks, empirical analysis and modeling. That paper related how we can model and identify some important features of the network of the public transport networks, mostly local and global characteristics, and how to use it and how it's applied to transport networks. That case study talks about the representation of the networks. There are a few ones and a lot of spaces to represent it, that kind of networks. And well, the challenges that we face that are the datasets information that we gather. Principal, we are working with Transmilenio information about validations in the entrance of the stations, and also, as everybody knows, we don't have information about the specific exit of an user in the stations. Therefore, we need to identify how this mobility pattern works with the information that we have.
Okay, so based on that, the network data sets that we have, and we already found it in two sources. One is from Datos Abiertos Bogotá, and the other one, I quite don't remember the name, but we have the feeding data that is categorized with these variables. We have the station, the type of access. This type of access is, for example, a north entrance, south entrance, west entrance, this kind of information. And as you can see, we have 387 different values. This is because we have the information is not like segmented with just the locations, but for example, disabled north entrance, disabled south entrance. So we'll need to like perform a data adjustment for these kind of types. We have the transaction date, that it will be the date of the collection, the value. This is for the feeding. It will give us extra information because it will help us to identify the transshipment, because when a cost transaction is 0, we can assume that it was from a transshipment from SITP, and it was, and if it has a cost, we can assume that it was a regular entrance to the system. We have the card type. This is, for example, an anonymous type or a Tuyave type. So we can also identify the segmentation of users that have the personalization, or if they don't. And we have the profile type, because if they have the Tuyave personalized, we have 7 unique categories that are, for example, adult, elders, and things like this. So we can segment by this. And with the feed out data, we have the zone, that it consists of, for example, the routes from the Carrera Décima or Carrera 30 or things like that. And even though we don't have the information for the feed in, since the station are the same for the feed in and feed out, we can group by zones for both feed in and feed out. We have the type of access is the same that as here. We have the information group by bonds, but since we have the transaction date, we can easily map these two together. This information here is based on intervals of every 15 minutes. This one here is based on individual entries, so we will have to apply some agrupations in the feed in to match with the feed out as well. Because, for example, for a regular month, it is like 40K registers for the feed out, but for the feed in is a lot more because it is individual. So we'll need to group this based on the same interval, so it makes sense for us also in terms of performance. And we have the day, but we can extract the day here also for the transaction date, so we can analyze, for example, for particular days of the week and stuff. Also, we perform like an exploratory analysis when we have a lot of insights already. For example, known things like that the main routes is the Calle 80, or that the main stations are like the big trunks in Transmilenio. But the one important aspect to highlight here is these two, that, for example, as you can see in the graphic on the left, is the distribution in percentage of entrance and exits per month. So we have in every month is like the same, like 8.3 or something percentage. So what this means is that we have consistent data, because it represents the actual flow of users throughout the dates in Bogota. And in the right, we can see the distribution in a day per hour interval. So it's the same, it is consistent data, so it will give us great results. Because as you can see, here we have the peak in the morning peak hour, in the peak, and in the afternoon to night hour. So it is really great information that we have and we can use for our network.
So here in the proposed network, we present a bipartite graph since it helps to capture the relationship between two different set of nodes. Uh, Here we uh, present the segmented users as one set of nodes, and uh, those are segmented by the profile type that are in the right box. Uh, and the other set is corresponds to the stations, and the links between them are the users' entries over time. Um, we expect to gain insights about how the flow over time changes, and it will be reflected on the occupancy volume uh, that is represented here by the size and the color of the node. Um, Also, we are going to use centrality measures to identify the patterns, and also if what are the crowded stations, and so on. And if it is possible, we are going to use networks for this. And oh, I forgot the filters.
Okay, good.
Thank you.
And
This one?
that's it.
Good.
Thanks.
Go back to that. Just leave the please leave the previous slide on.
This
Professor.
one?
Nice, nice.
Okay, thank you for the presentation. It's a very interesting project. It's a very real project. As you say, you have information. You have the network. You have the information. What I saw in the presentation, the networks you are going to use are changing from day to day. It's a question.
Yes and no, because
Yes and no, okay.
we do have information that changes day by day, but overall it represents like the same average of entries and exits per station, because it represents like the regular daily basis of the citizens of the city. So even though it is day by day change, if we perform an aggregation by month, for example, or even by week, it will give great results. And if we want to see well, if we get to that point, to see like the behavior day by day, to see those specific changes, it could be done if we get to that point. That's the idea, but we'll see.
Professor, regarding that question, Professor, I think it's better if they just stick to a fixed network, right, for the project,
Yes.
rather than just maybe a dynamic network. So just maybe build the network at some particular month or week or whatever, and keep it there, static, and then you perform the analysis, right, Professor?
Yes. They say that the information from day to day is very similar, so they could take an average or something like that and treat the network as a static, for you could calculate all the centrality measures and all that. This bipartite graph that I am seeing is segmented users and stations. The purpose of studying this bipartite graph is to make predictions, or more specifically, what are you going to study in this bipartite graph?
Yes.
What we
Yeah,
wanted,
sorry, you allow me. What are the questions that you would like to answer
yeah,
regarding the network?
what we wanted to see is like every insight that we can take from the behaviors in the flow of entrance and exits from the stations. Because, from example, from a overall view in the exploratory analysis, we saw that there are, for example, some stations that are like using 0.2% of entrances exits. So these are stations that probably will need to take action in there, because probably in how much buses are we sending to there, or probably how much users are actually using that, or for what reasons. And for example, with the segmentation, we can know that those users are using those stations because of this, or these users are using this station because of this. So what we want is to extract every like insight that we can to provide information to the like the whole transportancy like environment, or anyone that is interested to take actions in this. So take every insight that we can, because as we said, what transportation is really really changing, really difficult to predict and everything. So this could help at least a bit with these small things, because we can see the overall behavior that we all know that, for example, the Carrera 30 and Calle 80 are always like stacked. But we can see, for example, what stations and in what in the entrance, north entrance or in the south entrance. So, for example, if you know that, you would avoid the north entrance and go instead to the south, for example. Things like this.
Okay, but excuse me, I see two different problems. I don't know if I am wrong. When you are seeing this network, I think that the things that you are going to study in this network is how it distributed the different segmented users in the different stations. How many old people are going to one station? If there is a lot of old people going to a station, we need more police or more help for the people. And the other is the congestion of the station that require I guess a different network, a network where the nodes are the stations, and the links are how from a station to another there's a flux. Okay, so I see two different problems. If you want to study what the stations are crowded, and to do something about it, you need perhaps a different type of network than this that I'm seeing. I don't know if I'm wrong, but
Yeah. Maybe Stephanie, you were going to say something, right, Stephanie?
Yes, I try to say the model enables to analyze the passenger demands on specific routes and stations. This is why we choose the bipartite
Right.
network,
okay.
and is to enable to uh, analyze the efficiency and the performance of the systems.
Okay, good. Yeah, maybe you want to because Manuel, you mentioned something about like we want to get as much as insights about as many insights about from the network. I think just focus on one or two questions that you could answer just based on this network, right? Just, even if it is
We
a simple question, just try to answer that question.
we are found three parameters in the review in the literature. We have connectivity, centrality, and maybe clustering coefficient. The connectivity is the number of routes that reach specific nodes, and the centrality is the importance of a node in terms of shortest routes. This maybe enables to see the efficiency and the performance.
Okay, good. Okay, very good. I think, right, Professor? I think this is a very nice, especially because, as Professor mentioned, is like very close problem here in our city, and it's very nice that you can use actually the open data that they have there. Very nice, very nice. Okay, I think we can go with one more thing before we take a small break, right, Professor?
Yes. Okay.
Yeah, very nice so far. So far, so good. So let's move to. Let me see. Team number 6.
Hi, teacher. Good evening.
Hello. One.
Okay, so let me share my screen. Can you see it?
Yes, we can.
So, Paula, are you ready?
Yes.
Go ahead, please.
Well, good afternoon. We are Paula Andrés Guevara Polanía, Paula Jimena Rodríguez Nepeque, and Juan David Ramos Lopez. And we are talking about information diffusion, in particular in a social network context. So let's denote by N the graph that represents a social network, that is the graph whose nodes are the individuals and whose edges are the specific social relationships between the individuals. These graphs allows the exchange of information, communication, and influence between the members of the network. Since social relationships can happen in various contexts, from personal environments of daily life to digital platforms such as Twitter or Instagram, or work or academic environments. The structure of a social network varies considerably depending on the way its members interact. Thus, the speed and intensity of information diffusion depend on the dynamics and topology of each network.
Okay, so this is a network structure of an online social group. And as you can see, there are highlighted the, the authoritative users. The authoritative users are the ones that have bigger impact in the network. So as you can see, the ones that are red are going to impact in the network, but the impact is not as significant as the green ones. So the case study in this case is going to be, well, we propose to study the information diffusion on social networks. Specifically, we are going to use the tweet CID. This is a data set collection of 5 data sets that were extracted from Twitter. At the moment, it was called Twitter because it was extracted in between 2015 and 2017. So as we can see here, the 5 data sets have these names. First week, second week, iPhone, Gucci, and Galaxy. The first week and second week were extracted in January 2017 on the first second week of the year. And those just were extracted from that, and they didn't apply any more filters. And the other 3 ones, the iPhone, Gucci, and Galaxy, were extracted by using the keywords iPhone, Gucci, and in the Galaxy, the Galaxies that's the one that have a little change. So they also did in the study that we are checking the one that we're going to use as a base for this one. They already did exploratory analysis, and they classified the tweets as this. There are 4 classes. The class 0 corresponds to the tweets that are not retweeted. So those are like orphans. Those are the ones that someone types something and no one cares about that. The class 1 are the ones that are retweeted less than 100 times. The class 2 are the ones that are tweeted between 100 times and 10,000 times. And the class 3 is the one that are tweeted more than those. And
In this case,
an important part before Paulo starts, we in the dataset we don't have the actual tweets. We have the data pre-processed. So the idea is to create a network based on this information, and we don't have the network per se. Go ahead, Robert.
Well, in this case, it's very important to understand that this investigation and this research is the impact that to has the diffusion of the social network. In this slide, I want to try to present the approach of the research presented. As previously discussed by my teammates, the idea is to analyze the diffusion and how it works through in the social network, specifically in this year, the name X and the last Twitter. Well, what content has more impact, meaning replication among and other aspects that is important in this social network. The literature places us in an information scenario where there are the tweets and data collect in approximately 2 weeks, like call it Juan to us and how to has the all the information. First of all, it's important to highlight that this section was divided into topics, and each of these describes, for example, number one, data collection and feature extraction. In this case, it's very important because how was to analyze the collection and extraction, all the information. Well, the idea in this case for the research is like utilize the some techniques of machine learning for identifying relevant tweets, classifying and extraction features from the essential information that has. Other thing that is very important is the feature. In this case, we need to focus in the complex feature from the social media network. This feature could include linguistic patterns, structures, etc. In the second one thing that is important to analyze is the modeling. How was modeling? How was interpreted the information? Like number one is the core of goal. In this case, and in this research, the idea is predict the information and diffusion. How was research? How was to take this information for to understand how was the impact in the environment in the social, because it's very used, for example, for governments, for people, for influencers, etc. And the last thing that I want to describe in this topic is the model types. The prediction could involve various techniques that they can use for try to analyze the information that could be the classification, because we can to understand the prediction and where the tweet will go viral, the hashtag. For example, other technique that is could be important in this case is regression, because we have to predict the number of reshares and several things that we can to use. Next, please. And this is a global idea of our proposed pre-project.
Okay, go back to the previous one, please, Professor.
Okay, this is a very classic and a very important application of networks, social networks, diffusion in social networks. Let me share again my screen. I want to show you the same article that I showed before, because the abstract of this article is very important for your project. Let me. Are you seeing my screen?
Yes, we are looking at the paper.
Okay, let me read this abstract, because this is very.
What is the title? The title, Professor, is because we cannot.
Excuse me. Evolving viral marketing strategies.
Yeah.
It's the same article that I have showed before. Viral marketing could be viewed as how to diffuse an information in a network, because diffusion of information in a network, it's directly proportional to viral marketing. Look, one method of viral marketing involves seeding certain consumers within a population to encourage faster adoption of the product throughout the entire population. This is, I guess, definition of how to diffuse an information in the network. However, determining how many and which consumers within a particular social network should be seeded to maximize adoption is challenging. This problem has not been resolved. It's an NLP complete problem to see it. Okay, a very difficult problem. When you have a network, which nodes you must seed with the information for an optimum diffusion. So here in this article, they define a strategy space for consumer seeding, and they studied various types of networks: random, lattice, small well, preferential. And this is a very complete study where the authors try to find the best possible persons or seeders for optimum diffusion. It's a very clear article, and I guess it would help for you, for the group. I've just put it in the chat. This, as I said, this is a very challenging problem. You have information of Twitter. My question is, as you said in the presentation, you have the information of Twitter, but you don't have the network yet. Okay, you have
Yes, that's correct.
Okay, there are tools. I guess Gephi and another programs have plugins for obtaining, building a network of Twitter messages or information from Facebook. But I guess there are other tools. I invite you to ask ChatGPT, for example, of tools like that could convert Facebook information in networks. If you investigate that and find the solution, perfect. But if not, you could ask me and I could help you with that. It's important that you have the networks, because it's the beginning of the project. And when you have the network, you can begin to analyzing, to see centrality measures, to see what model correspond to the network. It's an interesting project, and there are a lot of information. And so, okay, that's what I have to say. I don't know if Luis Fernando have anything else.
Just yeah, I think here, as in some of the other projects, the key idea is to build a network from the data set, right? One, so and the other things, of course. So that's very important that you guys keep that in mind, because once you have the network, then performing the analysis, just what you will need to do is to apply the methods that, as Professor mentioned, that paper can be used as a reference to see what methods you could apply, network science methods, right, Professor?
That's correct.
The key idea is to build the network, not for you, but for everybody else, because for some of you, the network is already built explicitly, but in some other cases, you need to construct the network from the data set. So that's going to be very important. So once you have the network, the rest is not going to be so difficult.
Okay, Luis Fernando, but let me reiterate that today there are many tools for building networks from data sets. This is 3 4 years ago it was very difficult. We have to do it
By
piece
hand.
by piece. I mean, today this there are a lot of tools, and I guess it's it's going to the tool, to the appropriate tool, and how you want to convert this data set, with what criteria you want to convert the data set to the network,
Okay.
and you can construct it relatively easily
Okay.
today.
Good. Very good. Very good, guys. So I think it's time to take a break. So maybe 10 minutes, please. So it's 7:40, 7:50. We'll be back. So we can stretch a little bit. So see you in 10. Thank you.
Thank you.
Thanks.
Okay, everybody back. I think we can move on. We can continue. Then team number 3, are you ready?
Yes, we are ready.
Okay, it's your turn. Thank you.
Thank you, Professor. Let me share the screen.
Okay, so good evening. Today we are going to present the analysis of flavor networks in Latin American cuisine. We select a comparative study of regional flavor combinations. So first, in the introductions, we talk about flavor networks. As we can see in the image, they combine the ingredients from different foods about different regions, but we're going to focus in Latin American countries. So our proposal consists in exploring flavor networks, and this through data analysis, and explore like some connections that help us to solve some culinary and nutritional challenges. And in addition, we will aim to discover how flavor networks can reveal interesting patterns and provide some ideas about optimizing recipes, preventing nutritional deficits, and improving health. The next, please. Okay, so the project goal and the scope. First, we are searching, analyze through network science theory, some flavor combinations in Latin American countries. We are going to search some differences and similarities for understand those patterns. And about the scope of our project, we select the flavor network and principles of food pairing study. So we are going to take it into account and analyze those flavor combinations using the network science techniques. This will help us like interpreting results and will allow us to draw some specific conclusions about American cuisines. This so we do that for analysis and focus like the evaluation about some culinary preferences and also nutritional combinations that can help us to identify some possible dietary interventions to improve health and also like the population uh, behavior in this topic.
Okay, we will talk now about the literature review. In first, the reference article is Flavor Network and the Principles of Food Pairing, and another articles that use the same network to solve particular problems. But before I talk about the problem, we need to talk about some technical definition, key technical definitions that are network science, that is an academic field that studies complex networks, considering distinct elements or actors represented by nodes, and the connection between the elements or actors as links or edges. And the concept of flavor network, that is a network that captures the flavor compounds shared by culinary ingredients, different ingredients, and the food pairing hypothesis, that it proposed that the ingredients pair well in a dish if they share similar flavors. That is a concept that works the paper. And the paper reference, and we have to see the preliminary facts, that is like the conclusions of the paper that we used to construct our idea. And then the preliminary facts is that the cultural diversity of culinary practice, as illustrated by the variety of regional cuisines, raise the question of whether there are general patterns that determine the combination of ingredients used in food today, or principles transcends individual tastes and recipes. And in the figure, we can see the relationship between the ingredients and the flavor compounds, as the amount with the size of the notes, the amounts of ingredients per recipe according to the type of population, and more relevant information about consumption practice and the foods used in the recipes and food in the different region in the world. We can see in these graphs that they cluster the different regions in North America, Western European, Southern European, Latin America, and East Asian. Okay. But we use some more literature for have a bigger case of study, because in the paper we see the study of the flavor compounds for cultural reason, but we want to complete with a healthness or a health reason. And we share in different papers that use this type of networks, or this network of these papers, titles like influence of sensory properties in moderating eating behaviors and food intake, network analysis and data mining in food science. But the most important that we found that is exploring food intake networks and anhedonia symptoms in a Chilean adult sample. This is important case because work the concept that we want avoid for in this work. Then searching for studies or articles, we found this, and the most important thing is in the study was found that the focuses on the relationship between anhedonia and food intake. Anhedonia is the inability or difficulty to experience pleasure, which can lead to a loss of interest in previously enjoyable activities. And in the context of eating, this may translate to a preference of high calorie and sugar sweetened food concede more pleasure. The conclusions of this study is that this study provides valuable insights into how anhedonia symptoms can influence food preference and intake patterns, with implication for population health and well-being. This may be relevant to our project as they allow us to explore how flavor combination in Latin America cuisines can influence the intake of essential nutrients, and where certain food combination could address nutritional deficiencies. As we can see, they work the flavors not just like a cultural thing. They work with this concept like in a topic of health, and how our our ingredients are well or not well in our nutrition, in our daily nutrition. And then we have our case study. For this, in the paper, maybe the most important conclusion or hypothesis that they work is the food branding hypothesis. That is, if two ingredients do not share a strong molecular or empirical affinity, they can become affine through a pairwise chain of affinities. Then they work relations in the different flowers of the different cultures in the world, as we can see in the graphic. And it's important to say that these cases of study or the cases of study that they work that important, that is relevant first it because this study applies network science to the analysis. It does a study analyze how flavor combination vary among different regionals kissness, which this is a key for our proposed projects, that we want to focus in Latin America, not all the world, just Latin America. And we want to add it the part of health, as we will see in the next graphics. Okay. As we can see, we have the different shared components in the different regions and how they work and they cluster this information.
Yes, basically, those graphics show us like the interaction, for example, this one, between the different cuisines, like Latin American, East Asian, and which like uh, kind of food they share between them. For example, I don't know, garlic, buttermilk, etc. So I will talk about our network dataset. So basically, our network dataset answer questions about culinary practice and food combination in different places around the world. So more or less are like 56,000 recipes provided for two repositories. So we have food and of these things cuisines like North American, Western European, Southern European, Latin American, and East Asian. Okay, so yeah. But for example, the cuisines that are in the datasets are Western cuisines, East Asian cuisines, and that those cuisines has some characteristics. For example, use pairs of ingredients that share many flavor compounds, or for example, in East Asian they don't share a lot of compounds. Next. So for our proposed network science approach, we want to understand how all the like combination of the ingredients in the cuisines are used commonly, like how the recipes work in each part of the world. Basically, the notes represent the ingredients and each represents the flavors components. So we want to identify key ingredients, do a comparative analysis of the flavor networks of different regional cuisines. We want to do centrally measures for like obtain the degree centrality, identifying key ingredients, and community analysis for identifying clusters, a group of ingredients that are commonly used together. Path analysis for like exploring the shortest paths between ingredients to understand like how they work, like inside the recipes. Basically, with all those information, like try to use nutritional information about the food and relate it with the statistics of nutrition of those parts of the world, and that's it.
Okay, good, Professor. Your comments.
Okay, thank you for the presentation, Sergio, Valentina. Okay, a very important topic now in network science. In 1992, two chefs from France decided to do crazy combinations of food. One of the combination they used was white chocolate and caviar. At that moment, it was crazy, but later it was discovered that the chemical compounds of those of white chocolate and caviar were similar in a way. In 2013, Albert Barabasi build an important network that is the base of all the networks that are now in use of flavor networks. It's a very important topic today. A lot of good restaurants use network science for new dishes. And you know that restaurants now are very different from last century. They are very different. It's very interesting that you are going to apply this theory, these flavor networks to Latin American networks. Excuse me, to Latin American food. Latin American food is a very rich in flavors, you know. Colombian food, Peruvian food. I don't know if there is studies, local studies about networks, flavor networks for Colombian food, but I guess if there's not information, I guess that you're going to discover the first network of Colombian flavors. I don't know. It's a very attractive, it's very interesting, and centrality measures and all that is an ideal tool for analyzing these networks. So I guess you have the networks, you have the tools. I don't know if any one of you has a restaurant in Bogota. I don't know.
No.
Or if you like food, but this is a very interesting topic.
Yes.
And I wish you success in this project.
Yes.
I don't know, Luis Fernando.
Yeah, no, I was a little bit concerned when in the middle when they were talking about the relations between the components or the elements of the recipes and some diseases, and I was like, wow. But then at the end, it became clear that you are not going to go that far. So I think it's nice, and I'm looking forward to the results of the analysis. Very nice, I think.
Thank you, professors.
And I don't know. Yeah, you answered already because one was asking whether the chili peppers were gonna be there among the components of the compounds of the recipes of the food. Very good, very nice. Okay, let's move on to team number 5, please. Very nice.
Okay, perfect. Are you hearing me very well?
Yeah, it's fine.
Yeah.
Okay, all the team number 5 is ready.
Yeah, please share the screen.
Yeah.
The presentation rather.
Okay, perfect. Let me share with you.
Please try to follow the instructions about the file naming and that, because it's confusing, you know. So try that will help us, you know. Please try to follow the instructions about file naming and that. Okay.
Okay, now the slide is already on the screen.
I think the slide is not available. The screen say click to exit full screen.
Yeah. It seems to click or something. There's some problem sharing the screen.
Yeah. I don't know if it's not possible to me to share. I don't know why. But if somebody else will help me.
Yeah, of course.
Somebody else share, please. Okay, there you go.
Thank you.
Okay.
Thank you.
Okay. Well, let's start with the presentation of our project. Our project is called Network-Based Text Analysis for News Content, a case study on a Colombian newspaper. And our team is confirmed by Ivan Alejandro Cruz, Martín Eduardo Spitia, and Alejandro Ramirez, Manuel Alejandro Ponte Ramirez. We start with the motivation, and our motivation is that awarenesses of the sources of news helps individuals recognize biases, interrogate narratives, and cultivate a discerning attitude towards media consumption. And it is because, of course, integration of network science into analysis in journalist content offer an approach to understanding the complexities of media narratives and their impact on public perception. For sure, this project is looking for targets a comprehensive in examination of textual data from the Expertador newspaper, you know, the classic or traditional newspaper, the Colombian newspaper. I mean to cover hidden structures and patterns in the newspaper issues, specifically on the period of 2024. This allows us to focus on a specific domain in the recent information. And we expect to deploy text and data mining and network analysis techniques, mainly network analysis for sure. And we want to, or we aspire to delineate key topics, discern information biases, highlight permanent entities and actors for sure, and they'll be providing insights into the primary sources of news that shape the Colombian public understanding of local and global events. Our main topics, or the main topics that we wanna cover, are gonna be the categories of political information, education, and technology. And what we expect through this analysis is to uncover crucial insights of that main topics and on the news, and trying to get that information to identify, analyze biases, is a main topic, key actors and main entities features in Colombian networks.
Okay, there is any question? Okay, I think so. So, okay, regarding literature review, we found that traditional analysis on newspaper mainly focus on descriptive and inferential analysis of raw text. So in general, what mostly of research is done about analysis on newspaper focus has example the image on the left, that is, for example, in this case, how artificial intelligence terms appear in different newspapers. So in this case, they found the proportion of those terms in American newspapers, and that is a descriptive analysis. And for our hand, we found that, for example, the second paper found how schizophrenia terms or schizophrenia topics were published in different newspapers.
and they use inferential analysis of raw text to make some conclusions. But there is an issue with that, and is that even though some insights were extracted and were found through those analyses, there are many relationships that are missing in this analysis. So, for example, when we want, for example, understand what relations are happening in the text, or for example, understand what are the key actors, or try to quantify what are the most important aspects through a text, maybe it's very difficult try to understand those only with a frequency of text, or for example, with some categories. So there are evidence that support that graph analysis might support better argument analysis, because arguments have no linear structures that they are difficult to convey through linear text. And that is very useful. Like, for example, the image in the right, we could see different entities and how those entities are related with different other terms in different semantics, which is very useful. So for our case of study, for example, this work, they treat to understand The Witcher. The Witcher is a very popular Netflix series about fantasy. And what they did was recollect all the dialogues between the characters. And after that, they create a connection between the characters. But how they create that? So the way that they perform that was, if a name of a character has a proximity of 5 sentences or less, then that means that some type of connection between those characters must exist. So using that, they created the network on the left. And after they created that network, they perform a community discovering. And that has a lot of sense because two communities were found around the characters, Siri and Galtat. That they are the two main characters on their mission to find each other. So that's interesting because that network connect with our intuition of that theory. And besides of that, they quantify the influence of each node or each character on the overall network. And this case of study is meaningful for us because they transform raw text into a network. That is our same case.
So, can you hear me? Yes, I think you
Yes.
can. So, well, as you know, any block of text is inherently unstructured because it is just a sequence of words, a sequence of data, but you simply cannot tell beforehand what data it is that you have in that text. So the first step for us is to take the raw data provided by the news articles at the newspaper's webpage and discern what it is that such articles, what data it is that such articles particularly provide. So here, for instance, you can see we are extracting 4 particular items: the article's category, the article's title, its date, and then, of course, we will have the content, which will be the entirety of the article. This is very important because otherwise you cannot do anything. And henceforth, it becomes very simple to construct networks from that discernment. Now, as to the particular types of networks that we are going to construe, we have especially 3 kinds. One, the first one here, the co-occurrence network, is what you know as a semantic network, but it is actually more of a lexicological approach to the matter, even syntactical, if you will. But the later one here, the knowledge network, that is most properly a semantic network, because the first one will simply take every word that appears within an article, and it will link it, as my teammate said before me, within a certain scope to every other word appearing as there as well. That does not really tell us much about concepts, but it does provide us with a foundation to further elaborate complex proper concepts, which is what we will be dealing with in knowledge networks. And then, of course, we have the very well known social networks with, should we say, human actors or institutions, etc. In this way, building these three types of networks, we will eventually arrive at an understanding of how the news outlet is associating, on the one hand, what is most important to us people, which is to say, other people's names, and on the other hand, key concepts, say, in the context of a particular debate around some important subject. So that's pretty much it. I think we have not mentioned, but until now, that we will be working with around 30 articles in each category. And I'd like to conclude on that. Thank you.
Okay, thank you. Yes, Professor.
Okay, thank you for the for the presentation. Let me share my screen again. I want to show you a web page that could be useful for the project. Uh, are you seeing my screen?
Yes.
War of Thrones.
Okay, I don't know if you, the guys who are doing this project, know about this web page or this project.
I didn't.
Okay, uh, look here. This is the network of an episode of Game of Thrones. Network analysis applied to various seasons. This was done about 6 or 7 years ago, this work. The person who did this work is a famous network scientist. Some videos of his name is Andrew Beveridge. Some videos of Andrew Beveridge are in the web page of the course. He did this work with other two researchers, and they won a prize of network science, a very important prize. Uh, I want to show you this because it's a very good work. It shows analysis that have to deal with centrality measures. It has a lot of information, and there are articles about that work. Very good articles, very well written. Uh, this is not directly related to a newspaper, but here, for example, from the book to a network, from the script, because I guess you know that I don't know much about Game of Thrones, but Game of Thrones, like many series, are based on books. There was a book, I don't remember the author of the book, that was the origin of the series, and they convert the book to obviously to a script. Here are more novels of the author, the series, fractal protagonists that had to do with mathematics. They call Andrew Weber is called the protagonist fractal protagonist for a very special reason, and 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 also has a tutorial here, a primer on network analysis. So I guess this is a very good web page that I think is related to the work that you are trying to do. You showing in your presentation three types of
networks
that you are going to use, no? Social networks, knowledge networks, and I don't remember the other network, but these are the networks that you are going to need for studying this newspaper. Very interesting project. I have only a final question. Why you choose El Espectador? For a special reason, or why did you choose that newspaper?
Before the answer, and also, I'm also curious about, like, because there are so many papers there, or articles that rather. Um, well, how are you going to? Well, first is what asked, why this newspaper? Um, how are you going to select or how do you choose the articles that you are going to analyze?
Okay.
Okay, we selected the El Espectador because we think that analyze local media is very interesting, and when we try to find a very interesting data set, we found that El Espectador has a lot of articles, and besides of that, has some categories, and we found that extract the information maybe through web scraping is a very good possibility in that web page. So we found that opportunity convenient and also useful for that use case.
Ivan, you
Okay,
were going
thank
to
you.
add something, Ivan?
Yeah, complementing on my teammate's answer, it is also that if you consider the rest of news outlets that we have here, uh, it's pretty obvious that many of them are quite dramatically biased. So I will not go into names, but I guess you all have a couple of ideas in mind. The idea is to explore a particular outlet that will allow us to actually find out something new, something we do not already know, because this is the highest value of this sort of approach to the news.
Okay. And yeah, who was it? One? You said you had better luck doing the web scraping on El Tiempo. Is that what you're saying? Oh no, Daniel. Sorry, Daniel. Daniel said so. Okay, but anyways, yes, it doesn't matter. But yeah, maybe you need to focus on a category of papers, of articles there. And just a final question. So are you going to analyze the three types of networks, or just maybe one or two of them? The concurrence network, the social network, and the knowledge network?
Okay, in our case, we think that we could start with co-occurrence network because that is more easy to create than the other networks. But if we found enough time, we of course we want to work in the other networks, and also we limit our work to three categories. But of course, if we can, we want to work with more categories and with more time frame because in this case we only select 2024 articles.
Yeah, I would say maybe just focus on a particular category and then perform the analysis of one of the initial network, and then if you have more time, then you can move to the other type of network. Very good, very good. I think very interesting as well. And hopefully we'll get new insights about this newspaper and some of the papers, the articles there. Okay, so now
Excuse me, Luis Fernando. I have a final observation.
go ahead.
I think social networks are very important because nowadays, when you read a newspaper or when you read an article of some person in the newspaper, there is a space for the users to comment the article, no? So, for example, I don't know, uh, uh, a political or or some author of Milsbertau writes an article, and above the article there's a lot of commentaries. These are very important today because the popularity or the impact of the article is measured in part by all the comments that are made online. So social networks could have to deal with that point. I don't know if there's information about that, but it's only an idea that social networks could be integrated because of that fact of today's newspapers, but it could be analyzed. I don't know. Thank you.
Okay, then. I don't know. Juan, are you saying that you cannot access the Game of Thrones network website? Because I just clicked and I could see it. So I don't know. Can you?
I put the link of the web page of
Yeah,
Game
but,
of Thrones
but
in
the
the.
one when Sebastian says that he cannot access it or something. Can you
Oh, let me see.
confirm?
Okay.
One. Anyways, okay. Please,
I'm
please
gonna I'm gonna
there
I'm going to.
because I checked and it's the link is where it's fine. But so let's move on to team number 4, please.
Okay, can you hear me there?
Yes, very well.
Yes.
Perfect. First of all, while as I'm shared the screen, something very funny happened, and we have the same idea that another group, and it's pretty much the same. So we're gonna still present our proposal, and yeah, pretty much that.
Yeah, that's not a problem. Maybe you can compete and see whoever gets better results. Right?
Totally.
Yeah, I guess no
So,
problem with that.
okay, I don't know if you can see my screen now.
Yes, it's fine. We see it.
Okay, then we're gonna start. First of all, good night. We're gonna present our project proposed. We're Oscar Rodriguez, Angela Cardenas, and myself, Pedro Angreken. We're gonna start with an overview of our proposal that is pretty much about identifying critical points, critical nodes in the Transmillennium public transportation system in Bogota. We're going to be focused in the stations, and we're going to use some data sets to analyze the various century like points along different times along the day. So we're going to use different kind of analysis like centrality analysis in 4 ways, and using graphic analysis to identify critical nodes, and also to make like a network along yeah, involving all the information we can have. And our objective is to present like a way to optimize the time or the moments of the day that some points or critical nodes, in this case, treating that like a network, can have more attention than during other times in the day. So we are going to present you 3 objectives we want to get in this project. The first one is analyze the time and demand characteristic of the public transport network in Bogota. The second one is identify critical elements in the public transport network based on an open data set provided by the Transmillennium for Bogota. And the third one is propose a new plan for the current public transportation network in Bogota, focused on improving the efficiency.
Okay. The problem, general problem, this is no clear identification of the critical nodes, stopping station, in the public transportation service network, Transmilenio, in Bogota. Because critical nodes, we want to know the reason, if it's for many people, for infrastructure of the finite, for a combination of the other factors. Two is not clear reason why because it is congested outside of rush hour. We want analyze this data, utilize different models. Next. And the context of the problem, we three topics. The first is traffic at different moments throughout the day's traffic experience, varying degrees of congestion. Is different in the Monday and the Friday or the Wednesday. In routes throughout the day, buses on different routes operate at variable intervals, which depend of the time of day. For example, a rush hour in the not rush hour frequencies of C15 service. And the people across the public transportation network, there exists diverse demand at the different stations and along various routes. Uh, for example, the amount of people is different in the morning and the afternoon, even in the same substation. Next.
Now we're going to speak about literature review. So, in our literature review, we have found several texts that not only present new metrics to understand transformation networks, identify their critical points, and comprehend their shining patterns, but also provide detailed analysis and data on the public transportation in Bogota with a specific focus on the Transmilenio system. So, among the aforementioned texts, we highlight three. First, origin destination matrix and efficiently in urban means of transformation Bogota's mobility analysis, where we obtain map and information about the most commonly used location and starting and ending points by user in their trips. At the second text, we have model for resource assignment to transit routes in Bogota transformation system Transmilenio. Um, this represents a model based on generic algorithms, query theory, and graph theory for the planning of the mass transportation system. And the last, we have the life flows centrally for identifying critical nodes in transportation networks, where the life flows the life flows centrality measure is present for allowing us to identify critical nodes in transportation networks based on various factors, like the time or the count of people. And now we're going to speak about the case study. Please change the slide. So, and now, um, as a suitable case study for this project is the research conducted by Artemis Saltoglu and Eusebi Calle. The name is Enhanced Connectivity Index, and you measure 25 critical points in urban public transportation network. So this study presents a bus system in a medium-sized city with 14 bus lines and 400 stops operating from Monday to Saturday. So to analyze that, to analyze it, um, the study introduced a metric called Enhanced Connectivity Index, also called ESI, 25 critical nodes and the activity around them. This measure is based in between the centrality and network efficiency measure. So when we analyze their approach and applying similar techniques to our own data set, we can identify critical nodes in the Transmilenio network and propose a specific intervention to eliminate congestion. So having said this, now we continue with the data sets.
Okay, in datasets, while we see presentation is curious, Team 8 and our team have same datasets. Before, remember in the Transmilenio network, test stops are the nodes. It's connect to each other one to one by sections, and finally, there are nodes tackling the different sections. Okay, we choose two datasets to use. The first describe the number of people who enter day to day during the different months in the months February, March. They are organized by time intervals 50, 50 uh, 15 minutes type access and by stopping the station. They match the screenshot the first data set. The second data set describes the number of views that come out of different routes uh, and, and where the bus stop. Okay, the idea is cross-boot for obtaining the most important nodes. In the next slide, explain, and both datasets has been cleaned and updated daily. Next.
Okay, now talking about the network science approach we're going to propose, we're going to use two different kind of analysis. First of all, and very important, is the graph analysis we're going to do for set like the network or along Bogota. We're going to treat all the system of Transmilenio as a network. So every station is going to be a node, and the routes are going to be linked, just like the normal um, distribution of the routes. Now, after that, we're gonna use four different kind of centrality analysis: the degree centrality, closeness centrality, betweenness centrality, and a vector centrality. Each one is gonna give us different kind of information. For example, degree centrality and a vector centrality is gonna be very alike. It's like a different kind of approach for the same uh, information we are gonna look for. The first one, degree centrality, is gonna give us information about the most important node, as they have most neighbors around him. Yeah, so it's gonna give us some kind of position of each node, but it's not gonna give us the information of how is that node like put it in the network. The closeness centrality is gonna give us the information the degree centrality is not gonna give us. How is because it's gonna find like the closest route along the network. So this is gonna give us a position along the whole network of each node and the most relative, like the most influenced nodes along the whole network. The between centrality uh, is gonna give us like identify the nodes that function that it functions is acting like a bridge between different kind of nodes set it in a in the network. For example, you have a lot of nodes linked in one side and a lot of nodes linked in the other side, but you have to link those two groups of nodes. That's why we're gonna use between centrality, and the eight vector centrality is gonna give us the information of the degree centrality along the whole network, so we can identify critic nodes along the day. It's a variable network because it depends in the time and it depends in the day. Uh, this fourth centrality analysis is gonna give the information about how is that critic node um, is set in the whole network. So this four centrality analysis is gonna like present a lot of information about the critic nodes in the whole network. So we're gonna identify those, and we're gonna be able to propose different kind of alternative we can make to make the Transmillennium transport system more efficient, or just supply the whole demand they are gonna have along the day in different times. And that's our propose. And thank you for listening.
Okay, Professor, can you go back to the previous slide, please? Pedro?
Okay, thank you for the
Yeah.
presentation. Uh, I think that there are two groups with the same topic, but I guess we could see if we can make two different projects for the same topic. Okay. For example, you are very interested in centrality measures in the flux of the network of Transmilenio. The other group is interested in the segmentation
Users, yeah.
of the user, old people, young people. Uh, there are bipartite graphs that have a lot of applications for prediction, and I guess that both groups could talk with each other and make complementary projects. I don't know, Luis Fernando. I guess this is
Yes,
perfectly
I think
normal.
the difference, the main difference is that they, as you mentioned, they want to answer different questions, you know. So though the data is the same, they actually the data set is the same, then they just will focus on different questions on different issues. So I think in the end it's gonna be two different projects, you know, because they are going to answer different questions, perform different types of analysis. So nice. I think it's nice that
Yes,
even that would be interesting for the class because you know using the same data set you can still answer different questions.
and Luis Fernando, the data sets are the same, but when you transform this data set to a network uh, with two different approaches, you get two different networks depending on how you transform the data set to a graph or to a network. So if the data set is the same, when you are transforming that to a network, the networks probably are going to be different because they serve different purposes, and I guess it's it's viable to do two projects of the same topic.
Yes. Yes, very good, very nice. I think it's also very nice. I don't know if the guys from Manuel and let me see, remember Stephanie. Oh no, sorry, it wasn't. So Manuel, yeah, Stephanie, Freddy, or Jorge want to say something because that was you for the other guys who had the same data set, right? Do you guys want to add anything?
No.
Okay, so we'll see the progress and how things go. But very nice. I think it's very interesting. And there are so many questions like to answer and so many things to improve there with this transportation system. I think finally, I hope we save the last for the, the best for the last year. So team number 9, please.
Good night, everyone.
Hello.
Hello, good night.
Guys, can you help me please with the presentation? I have some problem with my internet connection
So this
right
is
now.
this is
I
going to
have
be
this can
Daniel,
open.
Farid, and Juan. Go ahead.
Okay, hi everyone. As you know, we are team number 9, and we're working on network science to identify patterns in medical practices and potential indicators of fraud in SOAT claims. We are Daniel Gravito, Daniel Munoz, Juan Arias, and me, Farid Estepa. So please continue, Daniel. So our objective is to develop a network analysis in the area of health to identify patterns of medical practices and possible indicators of fraud in SOAT claims. For this, we will use some techniques, some network science techniques, to analyze the associations and dependencies between health technologies in order to improve the quality and efficiency of healthcare and contribute to the creation of data-driven clinical practice guidelines. So continue, please. Our case study. So as you can see at the left, in Colombia, there are approximately 17.6 million vehicles. 10.5 of those are motorcycles, and the others represent cars and trucks and other vehicles. This is important to notice that just 9.3 million of those vehicles have SOT. So there are a lot of losses. And why is this? So there is fraud. So in the middle, you can see that there are 456 million detected cases of fraud. This is because of IPS that do not exist, and there are several cases where chargers are charged. And we also can see that the 87% of the accidents, a motorcycle is involved. In 2021, 1.9 billions of accidents occur, and in 2022, 1 billion approximately. Okay. Besides, 6.4 million of motorcycles that do not have SOAT. And here in the center, you can see the companies that are in charge of this insurance. And in the next slides, my partners will express the context. So please continue.
Great. So we are focused on the address account. We as government pays some part of the invoice that SOAT creates, particularly that accidents that the vehicle that be part of the accident don't have SOAT. So we have to pay for these claims because we have to ensure the the health of the people, the derecho. I don't remember how you say derecho in English. So we have some troubles in the SOAT because we have a lot of incentives of the agents of this market to try to become some frauds. Specifically, we can find in the map on the left that some departments in Colombia has a lot of reclamations, a lot of invoice about this account, but it doesn't make sense because they don't have a lot of population of enough vehicles, but they have a lot of reclamation in number and in money. Also, we have a lot of, this is a public health trouble because a person that has an accident in a motorcycle has several injuries. Maybe they lost their lives. In many cases, this has impact along all the life of these people. So the idea is try to also see this problem like a public health problem and a problem that maybe all of us have to take in account. Other problem is that we have to take into account is the complexity of the healthcare. Maybe we can help me with the next slide, please. Thank you. So, what we are trying to solve this problem, we are using a data set. A partner of the team, we are talking about the data set later. But the idea is that in this data set, we have the information about the healthcare services that are demand of the force for the uh, for the people that has this kind of accident. So we can do many rules, association rules, using the a priori algorithm to create these rules, and also we can plot these rules in the way of a network. So the idea is to use these networks to solve the problem of the investigation. That these try to create some automatically and data-driven rules to find the way to 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 attack this problem of fraud in the fraud account. And next one, please. So for some diagnosis, we can get different kind of technologies, health technologies, and also different kinds of networks and patterns. And also one of the ideas that we can validate in the process is maybe in different cities we can find different types of networks, or maybe we can find some technologies that are too usual, so it's not very informative, so we can drop out of the data set, and this is part of the investigation. Next one, please. We can find another networks here. This is part of the first iteration of this work. We create this network and we validate that we can get the rules. Next one, please.
Excuse me. I have a question. Could you go to
Yes.
the previous slide?
Sure.
Uh, what are the semantic of the nodes and the links in these networks? The nodes are persons.
No, no. The nodes are technologies. So
Technologies.
yes. So
And the links.
the links are the association rules links. So maybe it's better if I share some of the rules. So the idea
Yeah.
is
One
yes.
example, I am not clear what.
Yes, give me a second. I going to share my screen showing one of these rules. But the idea is that if this is the derivative of the basket case analysis. So the idea is that if you need some kind of lo voy a decir en español, si necesitas una tecnología en salud, pues, o sea, cuando te vas a hacer una prestación en salud, tú necesitas que te apliquen ciertos tratamientos para que te hagan, por ejemplo, una cirugía.
But
Entonces,
wait. This was
ajá.
one of the rules that we stated from the beginning. No Spanish allowed.
Okay, great. Sorry.
You need to make yourself understood as possible.
Thank you. Thank you. Thank you. Thank you.
But yeah, again, I don't know because I see some points. Yeah, are you talking about also these are not primary data, raw data, but secondary data where you already perform some association analysis, right? Is that what you're saying? Some
Yes.
association rules.
Yes.
But
Yes.
I still don't get it because I don't see networks themselves, or unless I'm missing something. I don't know. I just see the points. Are there links there? I don't know.
Yeah,
Yes.
probably when I share the presentation, it can.
Yeah. Oh, okay. So so it's like an association just tells you that some variable is somehow related to another one, right? And maybe you use that a priori algorithm
Yes.
or something like that.
Exactly. Exactly.
A data mining algorithm that counts, like how many times something happens. Two variables that have the same value, right?
Exactly. Exactly. And you can find this kind of rules. Maybe if you can give me the screen for a second, so you can find this kind of rules using the association rule algorithm. And later you can, with these kind of rules, create this network graph. Maybe if I make zooming, you can find the connections.
Okay, got it.
Great.
Sorry, I will ask everybody, please, to stay for a few minutes to let them finish, and then so we can wrap up today's, presentations. Go ahead,
Daniel.
Daniel. We lost you.
Excuse me, I am talking with the mic off enough.
Yes.
So the project importance is to identify what is the high fraud in SOAT. What we want to do is construct a knowledge base that we can after review some sites like we saw in the map previously, like in the coast region of Colombia and in Valle, where we can make a comparison and identify routes that are not common and probably are used to generate uh, extra cost. The analysis of SOT clients fill it with the address and the ICAT account contain information on all healthcare services for individuals. There are some forms online that we get the data, and after that, the data is analyzed. Um, Conducting a medical relevance analysis based on association and dependencies rules and networks generated by them will allow comparisons between cities and centers with good care profiles and create an analysis like I told before. And this study can contribute to creation of clinical practice guidelines, not based on expert criteria, because this is not a medical guide construct, but is an what we can analyze from the data reside by the web forms.
Okay, like we Daniel say, the data sets we're gonna use are from forms that made the health service providers. These forms, and since 2017 until this year, we have more or less 3 millions of claims. We need to be clear this information is sensitive, and we only use the rules and the networks. The information behind that, we're gonna know because it's personal information of the person. Next, please. And the network science approach, we're gonna use the detection of communities, identify clusterings about the patterns of medical practice or areas with high level of fraud. Attain a centrality. The study centrality must identify the influence of technology in medical practices and identify keys of the system. That becomes a subgraph analysis who we're gonna use evidence to make guidelines of clinical practices. That's it.
Thank you.
Wait, don't please go back to the presentation. Professor, I don't know if it is clear what they want
No,
to.
I think the subject of the project is very important. It's a very important problem. Uh, I don't see clear the use of natural science in this project. I don't know. Maybe I don't understand very well the you're talking about patients, about SOAT, but I what is the main objective of the project?
Yes, and let me just complement the question. How do you expect to detect the fraud? Because yeah, you are going to build the networks, right? And then you're going to get some clusters or something like that from the nodes. And then what? How do you relate that to fraud?
Okay, we have the two hypotheses here. The first one is that we have some good cities. Maybe Bogota is a good city that has a good attention pet pathway. And we have some bad cities that has a lot of reclamation, but also that try to agotar, to finish the coverage of the policy. So we have these two hypotheses. Maybe we can create some rules in Bogota, a good city, and compare this one with Cali, maybe. And also the other part is try to find some suspicious practices, because if you need to make some kind of surgery, maybe you only need some kind of radiographias, right? So if you demand many other kind of exams, trying to get all the money that the 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 SOAT has, all the money that one police of SOAT has. This is the kind of idea that we are trying to validate, and if we can validate these rules, we can use this to get the information about the fraud.
Okay, so yeah, but it's not direct, right? Like the conclusion that about fraud, but maybe after some additional analysis, you can conclude that there is some fraud being there. But okay, so because you mentioned something about the maybe what you want to cluster or to find is the relations between the medical information, right? Like the type of exams or the type of what you call it, injuries that the users have.
Yes, yes, we can create this kind of networks, and we also can analyze only the networks and try to know to be so ambitious, trying to detect the fraud.
Okay, yeah, and I don't know. Yes, it's not very clear to me either, Professor.
Okay, fraud detection is a very important topic in network science. There are a lot of literature. I guess you have to think in what kind of network do you need to analyze it and detect the fraud. I don't. I see a lot of networks. I see 4 or 5 networks, but maybe there's only one network that relates people to accidents. I don't know. And with that network, you could detect the fraud. I I invite you to think what kind of network do you need for detecting frauds in your problem, and I guess this could be the solution to clarify your project. But I guess if you think in that, you could get the idea. It's my opinion.
Yeah, and I think we need to maybe go on a second round with you guys, maybe to try to to answer that question, that's the main question, how from the network you can actually get the conclusion of identify fraud. I think we need so just think about that and let us know as soon as possible. But I think the problem is very interesting. I think this is, as I understood, Daniel, was it Daniel Garavito? Was it like, is this part of your? I mean, you have access to the data, or whose data is this?
Yes, I have access to the data.
Okay, very good. I think it's very interesting problem. Okay, very nice, very nice. Oh, I'm sorry we kept you like 10 minutes later, but I just think it's very nice the work that you all have done. Like by the interesting problems that you have come up with and identified and presented. And also, let me congratulate you because I think you did very well on your presentation, right, Professor?
Yes, very interesting projects, very diversity in the projects, a lot of knowledge, a lot of work in all the groups, researching and finding articles. I guess it was a very good session and a very productive session today, Luis Fernando.
Yes,
Thank you.
and and also the English. I think you did very well.
Yes.
Like
It was a real challenge for all of you, but you made it. You made it.
yes, it's I mean it's very nice that how you actually presented the problems, and also this first exercise, as you have seen, helps you advance on the concepts and the topics that are related to data science, and we're going to go into that after continue in the next session. So sorry for keeping you so late, and so I think we can leave now, and you guys have a good evening.
Okay, good night to all of you. Thank you.
You too. Have a nice evening. Bye, everybody.
Have a good
See
evening.
you next week. Bye.
Okay, good
Professor,
job. Very good job.
some